Now here we're going to write the equation from the graph. So y equals, I see that we have a positive a value because this v is open upwards, and our slope, up 1, right 1, up 1, and right 1. So we have an a value of positive 1. You don't have to write that down because you could just leave it as an invisible 1. Then our vertex is right here at -1, positive 2. So that means we need to have +1 on the inside of our absolute value bars and a +2 on the outside. And like I said, you don't need to have this 1 there. It's not wrong if you do. It's just most people don't write that in. Okay, the next one, y equals. We are open downwards, so we know we're going to have a negative sign in front. And our slope, we're going down 2 and right 1, down 2 and right 1. So that means a -2 is out in front. And our vertex is at +2, 3, meaning we need to have x -2 on the inside and a +3 on the outside, because we're shifted right 2 and up 3. The last one here, let's start with y equals. We see we're opened upwards, so the a value will still be positive. And our slope, we're going up 1 and right 2. So our slope is 1/2. And the absolute value of x, our vertex is at -2, -3. That means we have to have x +2 on the inside and then -3 on the outside. When we're writing our equations or dealing with the left and right shift, it is always the opposite of what you would see. Our vertex was at -2, -3. So we need to have x +2 in those absolute value bars. On the outside, our k value, it is always exactly what you see. You can see that -3, -3, +3, +3, +2, +2, and then -1, +1, +2, -2, -2, -2, +2. So you use that highlighting to help you out if you need to at first. Last question here. Write an equation of an absolute value function with a reflection in the x-axis. So this part right here means a is negative. A vertical stretch, so that means the absolute value of a is greater than 1. And a translation so that the vertex is in the 4th quadrant. All right, and if you have forgotten what the 4th quadrant is, we have 1, 2, 3, 4. We want our vertex down in this area. So x is positive and y is negative, and I gave you guys that hint right here. All right, y equals. And there are multiple correct answers, so let's start with a negative in front because we have a reflection. And we just need any number in front that's bigger than 1. Let's go with 7. That was one of my hockey numbers. Let's go with that. X. Now, if we want to be in quadrant 4, that means we need to have a negative sign right here, because our vertex has to have a positive x coordinate. So let's go with 4. Why not? Now the y value of the vertex is negative, So that means we need to have a minus some number out here. Let's go with 9. The vertex of this function is positive 4, comma negative 9, which is in quadrant 4. Now, if you wanted to, you could have just said, let me pick a point in quadrant 4 first, and then create my equation based on that point. Either way works. So I hope that you're getting an understanding of the effects of what A, H, and K do in our absolute value functions. It is very important to understand this because A, H, and K are something to deal with, something that we're going to deal with all year. Now, the last thing that we're going to do is learn how to graph these with your graphing calculator. Here's my graphing calculator. And the directions are also written up here on how to get to the graphing calculator, and also some helpful hints on how to adjust your window. So what we're going to do is we're going to press Y equals, and we see our our graphing screen, and we're going to type this in. Oh, negative. And then to type the 1/2, there's 2 ways. You could type just 1 divided by 2, or on most calculators, if you press alpha and Y equals, you see this N over D, numerator over denominator, so 1 over 2. Make sure you press the right button. And then to get the absolute value bars, press Math. Go over to NUM and see the first one is absolute value. There is another way to get there. Let's see if there we go. Yeah, if we press the alpha key and the window button, it says abs. Whoops, we want to move our cursor over here. And then we can press X plus 4. Then move out of the absolute value, minus 9. And the reason why I like using the fraction instead of 1 divided by 2, well, it looks like my negative sign went away, is when I'm using a calculator, I always want to make my calculator screen look exactly like the problem. That way the calculator will do the things as I intended. Then we press graph. So a graph looks like that. And like I said, your domain for absolute value is always negative infinity, comma infinity. Our range, the largest y value is at our vertex here, and that's at negative 9. So the domain, negative infinity, comma infinity, and your range, negative 9. I'm sorry, negative infinity, because that's the smallest number, comma negative 9. And then the end behavior, as x approaches negative infinity, y approaches negative infinity, because the left side is going down. Both sides are going down here. And you could have also gotten that because of the negative sign. So hopefully you're getting the hang of domain, range, and end behavior. Those are terms and ideas that will come up a lot. So you really need to get into the habit of knowing how to write end behavior and what to look for. So far, we've graphed absolute value equations and described it. So far, we've described absolute value equations and then graphed them. Now we're kind of going to go in reverse and look at tables and learn how to write the equation based off of those tables. So when we have an absolute value function, the table must have 2 things. It must have a vertex. And we talked about what a vertex is when we look at a graph. Now we'll talk about what it looks like when we have a table. And the second thing we must have is the y values change by the same amount. Up or down. So what I mean by that is that the y values are going, down by 3 and then up by 3, or maybe up by 5 and then down by 5. So maybe instead of, or we should say up and down. So let's look at this table here. So what I like to do is I like to kind of say, okay, what's happening here from this y value to that y value? We're going down 2, down 2, down 2, down 2. Now I'm going up 2, up 2, up 2. So because my rate of change is 2, I'm either going down by 2, subtracting 2, or then I'm adding 2. That's a clue that it's an absolute value function. So then what is the vertex? The vertex is going to be that point where we change. Right here at 0, -5, that's when we went from going down by 2, -2, to up by 2, this +2. So this is my vertex right here. So that makes my h value of my equation 0, and my k value -5, and my a value will be is going to be +2, because at the end of the table I'm going up by 2. If these signs would have been reversed and it was +2 over here on the left and then -2 down here, then my a value would have been -2. So this is an absolute value function. The equation is going to be y equals 2, absolute value of x minus 0. You don't have to put the -0 and then -5. So instead you could have y equals 2 times the absolute value of x minus 5. Either one of those is okay. We're going to get to the point where we're not going to write the -0. Okay, here we're adding 4. -9 plus 4 is -5. We're adding 4 again to get -1. And then the y values go back down to -5, back down to -9. So now we're subtracting 4 as we go to the right side of the table. So we're adding 4 at the beginning, at the start of the table, +4, +4, and then -4, -4, -4, -4, -4. So this is an absolute value function, and the vertex is right here where we change. So my h value is -4, my k value is +1, and my a value is -4, because that's where we ended off right here. Remember, in our absolute value function, the parent one, that the x-coordinate of the vertex is your h value, and that the y-coordinate of your vertex is your k value. So that's where I get these from. So now we can write our equation, y equals -4 times the absolute value of x. Instead of writing x minus -4, we're going to write x plus 4, and then -1. Oops. -1. So thanks for watching. Make sure to smash that like button and subscribe.